Oh,
All
there
right.
it is. Yep.
Thank you, Lauren. So in Studio 2, we move away from denoting inputs and outputs by using standard logic to standard logic vector. And the main reason we do this is because we could have a bus, meaning a combination of wires together. So for example, if you have a 64-bit computer and you're trying to access 64 things that are one number, they should be referenced as one entity with the same name, but because there are 64 of them, maybe you can index them 0 to 63 and then individually refer to them using their index instead. That's what the main purpose is for using standard logic vector notation. You could do this Studio either way. So you could do this calling the switches, the 4 switches, as ABCD or SW0, SW1, 2, 3, or the better way or the more recommended way would be to initialize just one name, switches, in the entity, which is for input using the notation standard logic vector. In this case, it is going from 3 down to 0. So essentially, this creates switches parentheses 3, 2, 1, and 0. Just that one statement, right? As opposed to saying switch 0 in standard logic, switch 1, switch 2, switch 3, right? Instead of writing all those 4 statements, you have essentially made a vector to reduce the effort. And this actually is very helpful to uh, refer to one thing by using index and one name. In the same way, for the outputs of this 7-segment display, because there are 7 segments for the 7-segment display, we can individually call them segments, and you can refer to them as a vector 7 down to 0. Now, 7 down to 0 is 8 of them. So where is this 8th coming from? Because right here there's A, B, C, D, E, F, G. So 1, 2, 3, 4, 5, 6, 7. Where is the 8th coming from? 8th is actually a decimal point, DP. So you don't have to worry about that for now, but that's where the 7 down to 0, which is essentially 8 pins. You can do 6 down to 0 if you want, or you can do a 7 down to 0 and then connect the 8th pin to off, so you can force that to be off. I leave the choice to you. Now, because we are referring to them as vectors, all we would need is 3 statements in the entity. Now, to step back and look at what that is, it is just a black box. So the 7-segment display, in this case, I'm calling that name as display underscore driver. It has 4 inputs. Those 4 inputs are being referred to as the name switches as per the entity example. And the vector, standard logic vector, is indexed 3 down to 0. I shouldn't say 3 to 0. I should say 3 down to 0. You could have also used 0, 2, 3 instead, but that's your choice. Those are your 4 inputs. In the XDC file, when we have to map each of these inputs, no matter what they might be vector or single wires, no matter what they are, you have to tie each one of them to something physical on the basis 3 board. So that's the entire purpose of the XDC file, Xilinx design constraints file. So in the VHDL file, you talk about what goes on here, and you talk about what are the inputs and what are the outputs. In the XDC file, you map all the inputs and the outputs to something physical on the board. So that's how you can think of these two things, XDC and VHDL file, separately. Now coming back to this, let me erase here, this, here, here. I've got 4 inputs. So in my entity, I just write this statement. Well, not the entire, just this one. And this can be done very easily while you are creating that entity wizard. So in the wizard, you say vector, most significant bit is 3, least significant bit is 0, and you're done. Right? It creates a bus. So vector is a bus. So here, if you use standard logic, it is one wire, either input or output. When you use standard logic vector, there are multiple of them, right? So that's a bus. Multiple wires that are called the same name. The name is the same, switches, but they are referenced as 0, 1, 2, 3, and so on, like using the numbers. In this case, 3 down to 0. So they are essentially 1, 2, 3, 4 wires that have the same name going in, as indicated by the diagram over here for switches. It's like a combination of multiple ports, but they have a theme. They have a theme of being used for one objective, right? So switches are all inputs in this case. There are 4 of them, but they are serving the same purpose. Let's move on. How would you fill your entity? Well, I need to talk about everything that is connected to the block. I know the inputs. I've done that. I need to do segments here and anodes here. Now, there was a question. I think Roma asked that question about why anodes. Right. Here is the answer to that. A 7-segment display looks like this. How many of them do you have on your basis 3 board? You have 4 of them. So it's like 1, 2, and you have one more. Right. So if I was trying to display something only on this, what would I have to do? I would have to talk to these guys as 28 different outputs, right? 28 different outputs. Now, if you include decimal points, then you have 32 different outputs. And you would have to include all 32 in this list over here. All 32 of them. Well, 21 of them, you can make them off, but you will have to still make them off. And then you can reserve 7 of them for one 7-segment display being utilized. Instead, what you can do is this. Another trick to save pins is to use anodes. So simply you send the 7-segment display information using segments A, B, C, and so on. However, where does that 7-segment display information go to? That can be dictated by using anodes. So anodes is essentially directing which 7-segment display, leftmost one, rightmost one, or one of the middle 2, or all of them, or 2 of them, or 3 of them. All of that is being dictated by the use of this signal anodes. So now you have what? 7 plus 4, 11 outputs instead of 32 or maybe 28 if you ignore the decimal point, right? So I hope that is a helpful discussion about why we are using anodes in the first place. Let's see, there's a question from Anthony. Should we define those as 2 different vectors then? Absolutely, yes. So over here, you would have a statement called something like segments out standard logic vector 7 down to 0, or you can use 6 down to 0 if you don't want to incorporate the decimal point. I will leave that choice to you, but that will take care of the segments, and then you will need anodes because these are also output. Standard logic vector 3 down to 0. So everything that you see in this diagram will need to appear in the entity. What do you see over here in this diagram? You see switches, you see segments, and you see anodes. So all of them have to appear in entity. They also have to appear in XDC file. And in the architecture of the Vhdl file, you need to describe how are the outputs related to the inputs, meaning what goes on here inside the box. All right, let's see. Should we define these? Yes, I answered that. What pin would we connect those extra segments to? Well, we are not connecting any extra segments, right? What we are doing is we need the ability to control 4 7-segment displays. So I can control 4 7-segment displays using 28 different outputs, or I can control 4 7-segment displays by using 7 outputs that can be directed to one of the 7 segments or multiple of them. So by using the anode's output, you can direct which segments it is referring to, which 7-segment display port it is referring to. So if you look at the XDC file of basis 3 board, you will not see 28 different outputs. You will only see 7 of them, and then you will have 4 for the anodes. That's it. Next question here is, how would we tell it to set the first anode to be 5 and the second to be 4, for example? Brilliant question, Alan. Now, the way you answer that is by using magic, sleight of hand. How does magic work? If you do things very, very quickly, human eye cannot see it, right? So if I was displaying something on this one, say 5, here, let me do this. That's a very good question. So let's say I do 5 here, and your example is 4. I'm going to draw 4 like this, right? Suppose I'm trying to display 5 here and 4 here. If I direct 5 to this anode for 1 millisecond, and then I turn it off and I display 4 here, and 1 millisecond after I go back to 5, 1 millisecond after I go back to 4, and I keep switching back and forth at a very, very fast speed, 1 millisecond. Human eye cannot detect that. So for the human eye, it appears as if 5 is being displayed here and 4 is being displayed here. Does that help answer your question? So it's like magic, right? All right, so I hope we talked about, I hope we have addressed the entity question, right? Switches, segments, and anodes. How long do they need to be, and why do they need to be vectors, right? Okay, all of that is over there. We talked about the entity being a black box and what all needs to go over there. Next, by the way, all the outputs over here are negative logic, and I've addressed that in the document. So if something is 0, that means it is actually active. So the light will turn on, for example. And if you want to turn on the rightmost 7-segment display, then you will have to make that particular anode low, 0. and the others have to be set to 1. And I describe that using an example right here for anodes. So 1100 means, you see this, the right two are 0, which means the same thing will be displayed on the two rightmost 7-segment displays. So if you just want it to display on the rightmost one, then you use 1110. So that way only the rightmost 7-segment display will be getting the information. All right. Next, for the architecture, I describe two things. One is an easy way that I recommend, which is to use the when statements. An example of that when statements is over here. So for you would have to use, say, something like with switches select B is the output here. So in your case, it would be what? Segments. After that, you have how many? 4. So in this case, it will be, if you use 7-bit vector or a 8-bit vector, say if you use a 7-bit vector, which is 6 down to 0. If you use that, and you're going to have to do G, F, E, what is that? D, C, B, A, right? 6 down to 0. So segment G, so for a 0, if you wanted to display a 0, it would be that, right? So segment G is off, everything else is on. 1, 2, 3, 4, 5, 6, 7. And then when the input is, what is that? Just 0, right? You can indicate that 0 as simply this, X 0. So in hexadecimal 0. And then comma, you can go on to the next one. Whatever 1 is, when X 1 in hexadecimal. X is used to represent hexadecimal. And you can do all of this. At the end, you will need with when others. So that would be what? For 1111. What is that? When others. So that's 0, 1, 2, 3. So that's F, right? For F, you would need A, B, C, E, F, and G. Last one would be this. I will just write it over here. G is on, F is also on, E is also on, D is off, C is off, B is off, A is on. Oh, sorry. Right. When others. All the syntax wise details are over here. After you do that, you have essentially let the Vhdl compiler know that you have mapped all the inputs to outputs. Well, at least with the segments, you still need to worry about the anodes. So after you do all that select, then you add the anode statement like that. And then you work on the XDC file. There is a second way to do this, which is truth table method, which is a little bit tedious. But in this case, you are treating each switch, segment, and anodes individually as opposed to doing it in a vector format. And that can be pretty lengthy. It involves a lot of simplification. We are not ready to do that yet. So I have just put it over here for the sake of reference, but I'm recommending you to use the when statements or option 1 to do this. So you have you have multiple options to design the architecture of this, and using the with select when, that architecture can be very, very short, right? Only a few like 15, 16 lines in this, that's it. All right, so let me take a pause here and see if you guys have any questions. So for now, just please ignore these equations. These equations, maybe in a class or two, these equations will start making more sense. It involves the use of simplification strategies that we have not yet learned in class. So for now, I recommend you to use the with, select, when statements. Should I assign to anode in X? Yes. Again, whatever you see in entity, whatever is in the entity has to be in XDC. So you would have to have like this, right? Switches 0, 1, 2, 3, and segments 0, 1, 2, 3, 4, 5, 6, and then anodes 0, 1, 2, 3. All of those have to be there in the XDC, and they are referenced using a square bracket individually. But in the Vhdl file, you can address them as one name. Oh, so these are available. Where is it? Hold up, I'll show you. Where can I look at my, okay, I've got this. Okay. Maybe you guys can see this screen. I've got switches here. You only need 4 of them, so you just need that 0, 1, 2, 3. Actually, just that's that 4 switches. Then you don't need LEDs. You need 7 segments, so you need all of that. You don't need decimal point. You can switch it off if you want, but you don't need this decimal point. You need 6 down to 0 for the 7 segments. And then if you go down here, AN, these are the 4 anodes.
And that file is located under resources in Piazza.
Yes. So this is the master basis 3 file as a text format that you can open. It's under studio resources. So you've got 4 anodes here, 7 segments over here, and then if I go further up, I can get 4 switches from here. All right, other questions, guys? Let me stop sharing this. Maybe it'll go back to you. Maybe it'll go back to me. I don't know. All right, I think that's all I got.